Hello everyone. So let's start with today's session. Today we are going to do the revision of discrete mathematics. It is also as DMS. Okay, discrete mathematics. So this is the only subject left to revise. Rest all we have completed excluding aptitude. So aptitude is not something that we will have certain formulas and you will be able to solve that. For aptitude, if you solve more and more previous year problem, then you will get the idea that from what space the questions are asked, and likewise you can prepare for aptitude. Okay, so if you leave aptitude and the rest all the subjects are covered, so you can go once on the playlist. Okay, it's there in the sequence, you can just pick up and can revise that quickly. Alright, so today is all about DMS. So the class is going to be of 1.5 hour. Okay, so let's discuss. I hope I am audible. Okay, so let's discuss the formula now. Okay, so if n objects are there, okay, with n1 distinguishable objects of a first type, okay, of a first type, same is for n2, okay, same is for m2 of second type till nr, okay, till nr where n1 plus n2 plus nr is n, okay, then n factorial by n plus n1 factorial, n2 factorial till nr factorial. It is like that. Okay, and this is a linear arrangement. Linear arrangements. Okay, linear arrangements of the given n objects. So please note down this. This is the first formula. Okay. So let's see the second one. N plus r minus 1 factorial, r factorial, n minus 1 factorial. So this is consequently the number of combinations of n object taken r at a time with repetition. Okay, n object taken r at a time with repetition. Okay, so this is the formula. Third is x1 plus x2 till xn equals to r, where xi is greater than 0 and 1i is smaller than n. Okay, so here is that this is formula for the number of selections with repetition of size r from the collection of size n, and the number of ways r identical objects can be distributed among m distinct containers. Okay, so this is the formula. So permutation and permutation is very important topic in discrete mathematics. So you should have knowledge of little formulas. Okay, R is for identical, N is for distinct. Okay, fourth one is A union B is equals to A plus B minus A intersection B. Alright everyone, so just notice okay, so let's see the next one now. Next one is A union B union C, and this will be A, B, C, A intersection B, A intersection C, okay, minus B intersection C plus A intersection B intersection C. Okay, and after that the sixth is de-arrangement formula. Okay, so dn equals to n factorial 1 plus, okay, 1 it's minus 1 minus 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus so on minus 1 n by n factorial, like this. Okay, So like this. And after that the seventh is, so divisor, okay, which is n. If you get a prime, just do 1 minus p1 by 2 till the time we have prime number 1 minus p1 by k. Okay, so like this you need to do. Okay everyone, so note this everyone. pigeonhole principle, so if k is positive, about pigeonhole principle, k is a positive integer and k plus 1 or more objects are placed into k, boxes, then there is at least one box containing two or more of the objects. Okay everyone, now let's see the next formula, x plus y to the power n. So this is treated as nc0 x0 yn plus, so let's remove this, nc1 x1 yn minus 1 plus nc2 x2 yn minus 2 plus okay ncn, so like this. Now the 10th one is nc0 plus nc1 plus nc2 so on, ncn is equals to 2 to the power n. Okay, so note these formulas, 2 to the power n. Note this everyone. So well, what is your what is this like your life science syllabus, ma'am? Means life science syllabus means life science syllabus, what that mean? Can you elaborate this more, what you want to say? So are you there? Are you there? Okay. Okay, so let's see the next one now. Okay, 11th one, nc0 minus nc1 plus nc2 minus so on. Okay, so on plus minus n ncn equals to 0. Okay, Okay, everyone. Any doubt in this? So 12th is 1 minus x. So it is like 1 x square and so on. Okay. This is the series. And the answer we get is 1 for this. So the coefficient of this is 1. Okay. Now let's see the next one. 1 minus ax. So this comes out to be ax plus ax square and so on. So the coefficient is a to the power k. Okay. So 14th is 1 minus xr. So this is 1 xr plus x 2r and so on. So this is 1 if r, and if it is k, so if k, so it is okay if 1 when r divides k, 0 otherwise. Okay, 0 otherwise. So the 15th is 1 minus x square. So the series is 1 plus 2x plus 3x square, so on. The coefficient is k plus 1. K plus 1. So note this, everyone. Okay everyone, now let's see the laws of logic. Okay, let's see now the laws of logic. I hope this is absolutely clear. Okay, so in laws of logic, see, this negation p is nothing but negation. This is equivalence symbol. Okay, means from here to here also it is true, and from here to here also both are same. Okay, so this is equivalence symbol. 17th is negation of p or q. So this is negation p and negation q. 18th is negation p and q. So this is equals to negation p or negation q. 19th is p or q is equals to q or p, because it follows commutative, okay, property. After that, p and q equivalence is p and q and p. Okay, it also follows associative law, which is p or q or r is equivalent to p or q or r. And 21st is p and q and r. So this is equivalence to p and q and r, like this. Okay, so this is distributive law. Okay everyone, any doubt till here? Okay, so let's see the next one. Now, idempotent means (22) P or P is P. P and P is P. P or F is P. So this is identity law. This is idempotent. This is identity. P and true is P. Okay, and P or negation P is true, P and negation P is false. 25 is domination law. P or true is true, P and false is false. So 26th is P or Q and P and Q is nothing but P. P and P or Q is nothing but P. So this is absorption law. Okay, this is absorption law. And the most important is P implication Q is nothing but it equals to negation P or Q. Okay, and 28th is P implication Q, which is implication so negation Q and implies negation P. Note this everyone, very important. Okay, now the next one is A implies B and A implies C, equivalence of A implies B and C. 30th is A implies B or A implies C. This is equal to A implies B or C. Okay, so let's see the next one now. So same you can do for OR. Okay. So like A implies C and B implies C. So this is equals to A or B implies C, like this. 32 is A implies C or B implies C. This is equivalence to A or B implies C. A and B implies C, like that. 33 is P implies Q. This will give you the result Q. Okay, this will give you the result Q. And this is the rule of detachment, which is modus ponens. Okay, 34th is P is implying Q and Q implies R. So this will give you the result P implies R. And this is law of syllogism. Okay, this is by the law of syllogism. And 35th is P implies Q, negation Q. So negation P, okay, it will give the answer. This is modus tollens. Okay, 36th is P Q and this will give the result P and Q. So this is the rule of conjunction. Okay, this is the rule of conjunction. So note this, everyone. Thirty-seventh is P or Q, negation P, this will give Q. This is the rule of distribution syllogism. Okay, 38th is negation P implies F. This will give the result as P. Okay, because this is the law of contradiction. 39th is P and Q and this will give the result as P, and this is the rule of conjunction simplification. Okay, note this, everyone. Fortieth is P gives P or Q. Rule of distribution amplification, it is called as. Okay, which is written as P implies P or Q, like that. And here 41th is P and Q. P implies Q implies R and this is R. So this is rule of conditional proof. Rule of conditional proof. Actually it is like this, P and Q, and this two statement, between two statement there is AND operation, and in everything whichever I have covered till now, in between two statement there is AND. Okay, and after that P implies Q R, and this is giving the result as implication of R. So implication works here. If any of the statement is there, so implication is working like this. See, this is the statement, and if directly this is there, it is acting as implication. Okay, so do understand this thing, how to write like this. Okay, (42) is P implies R, Q implies R. This will give you P or Q implies R. Okay, So let's see the rule of constructive dilemma, and this you have to learn as it is. Okay. P implies Q, R implies S, P or R, this gives us Q or S. Okay. 44th is P implies Q, R implies S, negation of Q or negation of S. So this will give you negation of P or negation of R. Okay. Any doubt, everyone? So let's see the next one now. 45th. Okay, so let's see the next one. So see this. For all x, okay, for all x, P of x and Q of x is equivalent to for all x, P of x and for all x, Q of x. Second is for all x, P of x or Q of x, for all x, P of x or for all x, Q of x. Third is there exists x, P of x and Q of x. So the symbol will be like this. There exists x, P of x and there exists x, Q of x. Fourth is there exists x, P of x or q of x equivalents to there exists x p of x or there exists x q of x. There exists there for all x, okay, q of x, p of x. So for all x p of x, there exists for all x q of x. Sixth is for all x p of x, q of x, for all x p of x, there for all x q of x. Okay, so note this everyone. Okay, so done everyone. So all you have to use this, sum you have to use this, not all it's like negation, for all like this. And no or none for all x like this. Okay, so let's see. So see about logic, set and digital. So the difference is here or is represented like this, and in digital it is represented like this, and is represented like this, and in digital and is represented like this. Okay, true is represented like this. Okay, and here in set it is universal, and in digital it is represented like this. False is represented like this, in set false is this, and in digital it is 0. So whatever the operations we have seen here, can you just do that for digital as well? Okay, we have done p negation p like this, so can you do for the set theory? So it will be like this, p. Okay, just you have to change the symbol like that, nothing else. Any doubts? Okay, so let's see few more operations. If A subset of B and B subset of C, then A subset of C. Then A subset of C. Second, if A is proper set of B and B subset of C, then A is proper set of C. Third is, if A is subset of B and B is subset of C, then A is subset of C. Fourth one is, if A is a proper set of B and B is proper set of C, then A is proper set of C. Alright. So note this, everyone. Okay, so let's note the next one now. A cross B intersection C is equals to A cross B intersection A cross C. Second is, A cross C B union C is equals to A cross B union B A cross C union A cross C. Third is A intersection B cross C is equals to A cross C intersection B cross C. Fourth is A cross B intersection C is equals to A cross C union B cross C. Okay, so note this everyone, it's very important. So let's see the next one now. First is, see, the general condition is f is a function, f implies b with a1 a2 is subset of a, then first point is f a union a1 union a2 is f a1 union f a2, function of a2. Okay, second is function of a intersection a2 is subset of function of a1 intersection function of a2. Third is function of a1 intersection a2 is equals to function of a1 intersection function of a2 when f is 1 to 1. F is 1 to 1. Note this everyone. Any doubts? Okay, so let's see the next one now. I hope you all have noted this. So the next is f if a implies b, so total function is b a, number of b a to the power a. Okay, and if it is 1 1, then for all a, for all b, f of a is f of b, which implies a equals to b. So the number of functions is permutation of b and a. Okay, so p is for permutation. Now on to, so right hand side, rs right hand side must be full. Okay, so which is summation of I to 0 till n minus 1 I into n c I into n minus 1 m. Okay, and if it is 1 1 and if it is on 2 as well, so it's nothing but n factorial. Alright, so note this everyone. Okay, so let's see the next one. G of f is 1 to 1. Okay, second is if f and g are onto, then g of f is onto. Okay, and if f is a implies b, g is b function c, and h is c function d, then h of g of f equals to, okay everyone, so this is the property, and actually this is a associative property which you should note. So note this everyone. Okay, so let's see the next one. F so they are invertible functions, that means inversion exists. Okay, then g is also g of f is also invertible, and g of f inverse is like this. Okay, all right everyone. Now after that we will see reflexivity, symmetric, anti-symmetric, all these properties we will see. Okay. Okay, so let's see reflexive. So it's R relation A relation A, and which is 2 to the power n square minus n. Second is symmetric. A relation B is implies B relation with A. Okay, which is 2n n square minus n by 2. Third is anti-symmetric. Which is 2 to the power n 3 n square minus n by 2. Okay, anti-symmetric, you all know that A relation B and B relation A is not equals to, if it is like this, A is equals to B, if not equals to. Okay, asymmetric means A relation B implies A relation not with A. So this is, sorry, it's B. Okay, this is 3 n square minus n by 2. Okay, so transitivity means A implies B, B implies C, so A will also imply C, like that. After that we will see some graph thing. Okay, so note this till now. Okay, now let's see the next one. First one is degree of v of I is 2e. Okay, the sum of degree of vertex is equals to 2e. Second is number of odd degree vertices in a graph will always be even. Okay, third is g is smaller than equals to 2e by n, which is smaller than equals to g smaller than n minus 1. Okay, fourth one is in simple graph at least two vertices will have same degree. Fifth is e smaller than equals to n minus 1 by 2. Sixth is 2 to the power n minus 1 by 2. Okay, seventh is degree smaller than n minus 1. Okay, n is number of vertex. Note this, everyone. Okay, so let's note the next one. N minus k is smaller than e is smaller than n minus k plus 1 by 2. Ninth is if degree of g is greater than equals to n minus 1 by 2, then G is a connected graph. If G is disconnected, then G bar will be connected. Alright. 11th is if graphs contains exactly two odd degree vertices, then path will be available between these vertices. Okay, everyone. Done. Let's see 12th. Maximum number of edges E in bipartite graph is smaller than n square by 4. Alright. So I hope there is no doubt in this. Okay. So all the best everyone for the exam. I hope if you have practiced well and if you have revised everything, then surely you are going to succeed in the exam. Okay. And thank you for watching this series. I think that it is helpful for you all, and if it is, then please comment it so that I can get to know that to whom it was helpful. Okay. So thank you so much everyone for watching. So do let me know if you have any doubt.